All right, guys, so let's go ahead and begin then. Oh, I'm going to get rid of this guy right here, closing down for good, and go from here. All right, guys, so let's put a little hashtag simple table example in here. So we've got this for future reference. I decided what I'm going to do for this one, guys, is just write a simple table first so that later on when we put these into functions, it'll be a little clearer about what's going on. Okay? So we are going to start, we can put any sort of like, bit of math in here, but let's say we're gonna plot the slope or something, okay? And you guys are always in algebra plotting slope, right? Y equals mx. Good old y equals mx plus b, right? Do we still use that terminology? Okay. All right. Good old y equals mx plus b. So here we go, guys. This is what I'm gonna do. Um, I'm gonna put a print function in here, and I'm gonna go ahead and give my table a title. So I'm gonna say table. And in this one, we can totally make it up. Y equals 3x minus 4, something nice and simple. Okay, so that's going to be the title of my table there. If you guys want to say this is a simple table, just in case you don't believe it's going to say that, there we go. Table y equals 3x minus 4. Okay. Now I want to put a little space in here so it's not too clogged up. So I'm going to use the double quotes here. And now I am going to write the following. So what I want here is I want basically a T-chart. I want my X, and then I want my Y. So when I go to plot this on my graph, it'll be nice and easy, okay? So what I'm going to do is I'm going to say print, and I'm going to put in here in quotes X. So that's going to be the X side of my T-chart. I'm going to put a comma in there after X because I'm going to insert something different now. Using the single quotes here, I'm going to put a single quote, I'm going to put a backslash, and I'm going to put a T in there and end that with a single quote. Okay, ignore whatever that is saying there. Okay, so do you see what I wrote there? So single quote, backslash T, end quote. What that's going to do is it's actually going to, that's the little function for tabbing over, okay? That way I can keep things within my writing nice and clean. Okay. The beauty is I can actually use this between, variables. I can use it between, different operands, and it works just fine. Okay. So I'm going to put another little comma in there. And the other side, so what I've done is I've written X, I've tabbed over, and now I'm going to put in on the other side my Y. Okay. And then I'm going to end with a parenthesis there. All right. So if you want to run that and see what it looks like, it's going to look like that, okay? So you see here it says table y equals 3x minus 4. Now I've got my x. I got a big space there without typing one in, and just like tab on the keyboard, it will keep everything aligned. Whatever I put in here, if I want to put more lines and I keep hitting that tab, it'll make nice, clean lines in there for me, okay? Now, just to keep it even cleaner, I'm going to do something else. Actually, I'm gonna copy this code right here, Control C, and then Control V to put it in here. But under that X, I want to sort of distinguish that. Remember, this is a T-chart, so I can't really draw a line down the middle on here, but I can draw sort of a line across if I replace that X with like 3 dashes, and I replace the Y with 3 dashes. Okay, it will allow me to see something that looks more like this, and that looks a little cleaner. Okay, so now I've got my table y equals 3x minus 4, x, y, and now I'm going to kind of separate those from the values that I want to use. Okay, I'll let you guys get caught up to that point here. I think I still hear a little bit of typing going on. Okay, now what I want to do, guys, is I want to actually be able to generate a list of numbers that I could plot out here, right? So if I wanted to calculate that, so I'm going to use a for loop here. Okay, I'm going to say for x in range. How many numbers do we want to plot? 10. Okay, so I'm going to put in range 11. Okay. Remember, because when it counts to 10 in a range, it's going to go, or it counts to 11, it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and stop. That'll be our 11 numbers. Okay. All right. What I'm going to do then is for that range, and I say x, we can make it I, we can make it a, it doesn't matter. I'm going to print the following. I am going to print out x, okay? Notice I'm not putting that in quotes. because the first time it runs through this, x will be 0, right? That's what it's going to do. So it's going to actually print out 0, okay? Now I want to put in that tab function, okay? So get rid of that thing. I'll put in x. So it'll print out under that x column over here a 0 the first time through, a 1 the second time through, all the way up to 10, okay? Now what I ran here was 3x minus 4. So what I'm going to put in here is I'm going to type in 3, okay, times x. I got to use my star. So this first time it'll be 3 times 0 the first time through, right? And then minus 4. Is that what I did? Yeah, minus 4. And then I can close up my parentheses there. All right, and it should be good to go. So when I run this, the first time through it'll go 0, so it'll be 0, and then negative 4, right? Next time through it'll go 1, so it'll print under 1, tab over, and then negative 1, right? So try it out. Go ahead and run it. Boom, there you go, right? A nice easy little table there. It looks pretty good. I could now, take it to my graph paper and go ahead and plot out that line if I wanted to, right? And we could make them more complicated, guys. Feel free using this simple little system here. What if I do, let's go, what if I take 3x, squared or something like that, okay? I can do that. I just went and switched the y equals 3x squared up here. So down here, I got to make sure I do that too. So I got to go 3 times x, and I got to square that. And now if I run it, I'm going to come up with very different numbers on here, right? There you go. Now in this case, I just made a simple t-chart, guys. You could easily make a chart that will print out, 3 lines on your table, or 3 columns on your table, or 4. And you can do that. It's really not a problem to do so, okay? So just kind of playing around with there, using a simple table, in this case using a range. Now what if I wanted to get some, negative numbers in there? I'm going to turn this back to 3x minus 4. Is that what I did, 3x minus 4? So 3 times x, subtract 4. I can put negative numbers in there too. Say I wanted to go from negative 10 to 10. So I can put in negative 10 and for my range, negative 10 to 11. And I can run that. And it's going to give me a much bigger list, but I can see how that plotting works. So my negative numbers are in there just fine. Not a problem. So however big you need to make this, you could totally do that, right? It's really not a problem. You can make it really small if I wanted to. But I just negative 2 to 2. Boom, there you go, right? We can print it out, plot it out. So that's the usefulness of that right there, okay? Now let's do a little more complex one. Let's run one in with a function in it, okay? So we're going to hashtag this. We're going to call it table in a function, okay? Okay, I'm going to put a little more in this one here. Okay. So I'm going to define a function here. I'm going to call this plotter, and I'm going to set it with a parameter called x. Okay. And now what I'm going to do is with this little plotter here, I actually wanted to print something out specifically. Okay, so I'm going to do the following. I'm going to print, and I want to print value x. Okay. I want to tab it over, so I've got a nice clean place to work with here because I'm making a table. I am going to do, let's do x squared. Okay, so I'm going to take x asterisk asterisk 2 for x squared. I'm going to tab over once again. And then what should I do? Maybe square root of x or something? I can do that. So I can make a table. Here's x squared, here's the square root of x, right? Just, or something like that. So let's do that. So I'm going to put x and make that a square root. So there we go. There we go. All right, so my function is very simple. All it's going to do is take whatever parameter I put in here, and it's going to write that out. So if I put 1, right, this would say x is 1. It would tab over. X, or 1 squared, is just 1, so it would print 1. It's going to tab over, and the square root of 1 is just 1, so it'll say 1, right? It's going to just say 1, 1, 1 across the board. Now that in itself won't actually do anything until I call the function, right? So if I wanted to, I could do that. And by the way, I'm going to actually come in here and I'm going to make another space in here so again things don't get too cluttered as we run this over and over again. And I'm going to do that. Okay. All right. Oh, I forgot to call my function. So here, if I say plotter, like let's just try this out, guys. Let's do what could I do here? Let's do 9. Okay. So if I run plotter 9, watch what happens. There you go. 981 3. Okay. So I called my plotter here 981 3. I could put another plotter in there, call plotter, and this time just put, something else. What else works nicely? 4, right? So if I run 4, notice that it's tabbing those over. It's making them look nice and neat if I want to. Incidentally, guys, if things start getting too cluttered, you can put 2 tabs in there. You totally can. In fact, I feel like that is almost a little cluttered. So if I go back in here and I go ahead and put another tab in there, I can run this again, see if it makes it look any better. That's too far, right? That's ugly. I don't like that. I'm going to take it out. I'm just showing you that as you're working with these, you got to kind of mess around with it a little bit. All right. Now that's all fine and dandy there, guys, but I don't want to keep having to put something in here, right? So I should probably write something that will maybe loop through, right? So that I don't have to keep putting in some parameter for plotter. Why don't I write a loop that can put in a parameter for plotter instead, okay? So I can just take this out and do something for like this. For I in range, let's go to, I don't know, 17. All right. For I in range 17, and then I can just call plotter I, right? So it'll go 0, and I'll plug it into there and run it through there. So I can go ahead and hit F5 and say, there we go. There it is. A little bit ugly, but you can see it nonetheless. Actually makes it really clear, those kind of special numbers that look really nice. So what I've got here is I've got my x, I got my x squared, and I've got my square root. So if I wanted to, before running this range here, I could go ahead and tidy that up, right? I could say something like print, I don't know what we want to call it, value table, okay? And then I can print x, put a tab in there. What do I got? X squared, right? I'm just gonna, remember, I don't really have to type in x star star 2. I'm just giving it a heading, so it's really just a string I'm making here. Whoops. I've messed something up. What did I mess up? That's it. There we go. There we go. There it is. Well, I thought something looked wrong. And then, let's see, can I do a square root function? I don't think I can. Or a symbol? I don't know. I'll just type in 2 root. And then end that. If I run that, it might make my table look a little better. There you go. So there it says value table x, x2, 2 root, square root. And so I've set up a table. If I was really, worried about the tidiness, I could do this number here as well, which is the Control C, Control V is really nice here because then I could just take this out. Whoops. Replace those with some dashes to clean it up a bit. It's a bit of formatting stuff in this case. Right? All right, try it again. Whoops, what'd I do? Messed up something. Rent is not defined. Oh, huh? Yes, got to do the print. All right, so there you go, guys. We can just kind of play around with those things. So that's a table in a function, right? All right, guys. So if we look at this, once again, guys, your attention up here. If we look at this, what I did is in this case, I used the function to basically plot out, do my math points there, right? I still have a for loop outside of it. Now I want to show you that you can also call on a function sort of within this sort of parameter right here, okay? So we're going to do one more little hashtag here. This is actually the shortest one we write, a function in a table. Okay. This is a very, very short one. All right. I'm going to make a new function. It's going to be called adder. This is going to be one of the shortest functions you guys have probably ever written. All right. So I'm defining my function here. Define adder a as my parameter. And here's the entire thing. It is going to return a plus a. That's the whole deal. Okay? Return a plus a. So all that's going to do is whatever parameter goes in there, if a is 3, it is going to go 3 plus 3, which is 6, and it will return the value 6. Okay? So it's very, very short. If I wanted to, guys, I could say something like b equals a plus a, and then return b, but I don't actually have to do that. I don't have to do that if I don't want to. If I'm really just asking it to do something simple like that, I can just totally get rid of that variable b there. I don't need it to do that. I can just have it return a plus a. Okay? So that's my whole function right there. That's the adder function. All right. Now what I'm going to do is come back up here, guys, from your simple data table. Go ahead and copy those lines of code, those ones that say x and y, and the little dashes there. It just saves a little bit of time because I'm actually going to use an x in this case. Okay? And instead of y, I'm going to have x plus x. Okay? All right, so I'll print out x, tab over x plus x. Then I have these little sort of, clean it up, underline it sort of things. Okay? And now here's what I'm going to do. I'm going to say for x in range, it doesn't matter what the range is. I'm going to go negative 10 to 11 on this one. Okay? Print out the following. Print out x. That's going to be my x. Tab over. And then instead of printing out a plus a, okay, I am going to call on my function adder and have it input x for the parameter there. Okay? So I'll make a table now. So again, when it runs through this the first time, it'll say negative 10. So it'll print out negative 10, tab over, and then it's going to take adder. It's calling adder 10. So it'll come up here and take negative 10 plus negative 10. So that'll be negative 20. Okay? So I'll go ahead and run that. And there it is. Maybe I should come back here and put in a little spacer. Okay? I'm going to run it again. Whoops. There you go. Oh, yeah, you could. You could totally do this internal. So there it is, guys. There's the one I wrote. And note right here, this x plus x, right? In my little print function here, I actually called on the function that I wrote over here, adder a, right? I just returned a plus a. So again, 10, or negative 10. Negative 10 plus negative 10 is negative 20, right? You can check yourself. 2. 2 plus 2 is 4. Yep. 4. 4 plus 4 is 8. Yep. And so it works out just fine. So just trying to get to show you guys, man, you can call these functions wherever you see fit. You really can, right? If that function is going to provide a parameter for something else, by all means, use away. So just kind of getting used to this flexibility. We can do these things multiple different ways. Alrighty, guys, so there you go. Your assignment then is to write a little program that makes me a table. I don't care what, pick some math that you like, right? And somehow in there, use a function in that table. You could use it this way, like we did here, where the table was actually produced by a function, or you could use it down here, where the function actually was one of the parameters for the table. Or use it some other way. I don't really care. Okay? All right. You could even make it so that it you have to input the value for X and it will solve Y for you or something of that nature.